Hello everyone, and welcome to 7th grade Math Module 5, Statistics and Probability. In this video, we're looking at Lesson 18, Sampling Variability and the Effective Sample Size. Our learning goal is to make sure we can understand that increasing sample size decreases the sampling variability of the mean. A previous Eureka lesson investigated the statistical question, what's the typical time spent at the gym, by selecting random samples from the population of 800 gym members. As we know, random samples are generally more representative of the whole population, but at the same time, they are random, so we never know just how representative they are. Two different dot plots of sample means calculated from random samples of the population are displayed below. So each of the dots on this dot plot is the average of a set of data. So in the first dot plot, all of our means there, all of the dots, are coming from 20 different samples. That's the 20 different dots that each have 5 data points. So we picked 5 random gym members and figured out how long they spend at the gym and then found the averages. And that's how we got each of our dots placed. The second dot plot represents the means of 20 samples, with each having 15 data points. So both dot plots have the same number of dots, 20 dots. There were 20 sets of data collected. But for the first dot plot, only 5 people were surveyed in each set. And then in the second one, 15 people were surveyed in each set. So based on the first dot plot, Jill answered the statistical question by indicating the mean time people spent at the gym was between 34 and 78 minutes. She decided that a time approximately in the middle of that interval would be her estimate time of the 800 people at the gym. So that was about 52 minutes. Scott answered the question using the second dot plot. He indicated the mean time that people spent at the gym was between 41 and 65 minutes, but he also selected the same mean of 52 minutes. So if they have the same mean, these sets of means, then what are the differences that our dot plots have? Well, the first dot plot is a lot more spread out than our second dot plot. And remember, each of these dots is an average of a set of data. So when we look at the first one and it's all spread out, it's got a lot more variability. It makes it harder to really get an idea of if it's representative of the population, because if we think about this dot all the way on the right here, that shows people going to the gym for 78 minutes, but if we choose one of these over here, that's saying 34, and each of those dots represents a group of randomly selected people who are supposed to represent the average of the population, and they're at the extreme ends there. Whereas in our second one, because we had more people in each group that we then averaged together, what we found was that their averages were a lot closer to the center, a lot closer to what ended up being the average of all of our data here. So in general, do we really want our data to be spread out like the first one, or do we want it to be closer together like the second one? Well, the larger sampling variability, so we see a large sampling variability in here, the more that the value of a sample statistic varies from one sample to another, and the farther you can expect a sample statistic value from the population characteristics. So looking at that first one, a lot of our data was really spread out, and it was really far from what we were expecting, which was a bit towards the center of the data. You want the value of the sample statistic to be close to the population characteristic. So you want sampling variability to be small. So if I look up here at these two options, I don't want everything to be spread out like in the first one. I want things to be closer together and to vary less. Because if the averages of my different samples vary less, that means that they are closer to what is actually representing my population. So long story short of this lesson is the larger that our sample size is, the less that our information, our data will vary, and the closer it will represent what is true for the whole population. What does this video make you wonder about sampling, size, and variability? Write your questions down so you don't forget them. Then you can try to find answers online or ask a classmate or teacher. Thanks for watching, and when you're trying this on your own, remember, if you learned from your failures, then you succeeded.